Okay, good morning. Welcome to
Fun Math number 47.
Fun Math number 47. Today we're looking at another MOEMS problem. Just for practice before the MOEMS tests start in a few weeks. And here's the question. A fast clock gains time at the same rate every hour. It is set to the correct time at 10 a.m. When the fast clock shows 11 a.m. the same day, the correct time is 10:52 a.m. Okay?
Yeah.
When the fast clock shows 3:30 p.m. that day, what is the correct time?
Well,
Okay. Do you understand the problem?
yeah.
All right, so tell me some important things that are in the problem.
We've got a clock that gains time,
Okay?
the same amount of time every day.
Every
Hour.
So it means the same amount of time. Okay?
And it's set to the correct time at 10 a.m.
Yeah.
When the fast clock shows 11 o'clock,
Yeah.
the real time is 10:52.
Okay.
That means it gains 8 minutes. Well, there's an 8-minute difference.
Okay. And what are we trying to find?
When the fast clock shows 3:30.
All right. What is the actual time when the fast clock shows 3:30? Okay, great. What do you think is a good way to approach a problem like this?
Make a chart.
Okay, make a chart. All right. So
We've got the fast clock and the normal clock.
you go look and see if this is on screen.
Yeah, that's on screen.
Okay. So what's the first thing we know about the fast clock?
We know that it's set to the correct time at 10 a.m.
Okay, so you want to put that in your chart first?
Yeah,
10.
a.m.
It's okay to skip the AMs if you want. And the normal clock is 10. Okay. And what's the next thing you know?
Then the fast clock shows 11 a.m.
All right.
This correct clock is 10:52.
All right. Oh, don't forget those. Those are important. Okay. What's next in your chart?
Then if it shows 12.
Okay. When it shows 12, here I'll write that because there's a little bit of a shadow when you write over here. 12. Okay. What's the actual time when the fast clock shows 12?
Well, it's gonna be 12 o'clock minus 16 minutes.
Okay. So what's 16 minutes before 12?
That's 11:44.
11:44.
Is that right? 11:50. Yeah, that's right.
Is it? Okay, 11:44. So it loses another 8 minutes. Okay. What's next?
And then at 1 o'clock.
All right, at 1 o'clock, what time is it going to be?
It's gonna be 12:36.
12:36. Okay. Okay. What about at 2 o'clock?
At 2 o'clock, it's gonna be 1:28.
1:28. Very good. Okay.
And you have room for another one?
Do we have room for? No. Okay. At 3 o'clock, what time is it going to be?
2:20.
2:20. Okay, but they didn't ask for 3 o'clock. They asked for 3:30.
Well, it's half an hour, so it's gonna gain 4 minutes.
It's going to gain 4 minutes. Okay, so this in half an hour, this is 4 minutes faster. So how many minutes do you have to add to 2:20?
You have to add 4 minutes. So, yeah. Well, at 3 o'clock it's 2:20.
At 3 o'clock, it's 2:20. When this clock shows 3:30, we've got to figure out how much we need to add to 2:20. This is one of the tricky parts of this problem.
Well, if you add 4, except we have to subtract a little more time away.
We have to subtract a little time away from what?
From 2:20.
Oh, so you think it went when this clock shows 3:30? You think the real time actually went backwards?
No, it goes up.
By how much? That's what we have to figure out. This is 2:20. plus something, some amount of time. How far forward did we go on the broken clock?
We went 30 minutes.
Okay, so how much is 30 minutes on the bad clock is how much in real time? That's the question. How are you going to figure that out?
How much time? Well, you're going to gain 4 minutes. You gain 8 minutes every hour.
You gain 8 minutes every hour, so you gain 4 minutes every half hour. So what does that mean?
It means that we have to. No, that's not it.
Okay, so you got to figure out. Go back to the beginning. Okay, what do you notice about these first two columns? What's the relationship between these two numbers and these two numbers?
So these two to these two.
Yeah, what's the relationship? What do we know about the fast clock?
The fast clock is always a multiple of 8 ahead, except for the last one.
Okay, what else do we know? There's something very simple about the fast clock.
It gains.
Just look at here. How far did it go forward here?
1 hour, and it went 52 minutes.
Okay, so now simplify that.
So a half an hour would be 26 minutes.
A half an hour is going to be 26 minutes. Do you see where the 4 is there? Remember you said you lose 4. Where's the 4?
The 4 is, you have to add 4 to get to 30 minutes.
Okay, so when this clock goes forward 30 minutes, how far does the real time go forward?
It goes forward 26 minutes.
26 minutes.
2:46.
Okay, so 2:46 is the answer. Okay, so the thing to notice here that I wanted you to notice, you compared hours and minutes. How many minutes does this clock pretend to go forward?
60.
How many minutes actually went forward?
52.
Okay, so you're comparing 60 to 52. Now you're comparing 30 to
20. Right here.
when it goes forward 60 minutes, how far does the actual time go forward?
52 minutes.
Okay, so when it goes forward 30 minutes, the actual time goes forward
26 minutes.
26 minutes. That's the important thing. Another way you could have done this problem is gone from 3 to 4.
Yeah.
And figured out what time the clock showed at 4 and then whatever number was in the middle. But this is a good way too. So to review, you see a problem like this where you're just counting forward a little bit, make a chart. And then the trick they threw in was suddenly you didn't go forward an hour, you went only half an hour. And so you had to figure out how far the actual time went when the fake clock said half an hour. And the answer was, how fast was it moving in half an hour?
It was moving 26 minutes.
26 minutes, okay. Good job.